Hello, everybody. Thank you very much for for the opportunity to talk to you all today. I'm the founder, CEO of Light Integration Technologies, and feel free to contact me at my email address there as soon as it's up and running again. All right. So Light Integration Technologies, I'll just quickly give a brief background on us. We're a very early stage startup, started last year with teams in Seattle, Washington, and Santa Barbara, California. Um, we are we're currently bootstrapped, operating on government contract work and contract work for our partners, but doing fairly well for being so young. And so then we're hiring. So please contact me if you're an expert in any of the things that I talk about today. Um, we're a vertically integrated developer of PIC-based products, primarily focused on scalable hybrid platforms, with DFMA in mind from the start. My background is developing PICs and laser systems for various applications, not just quantum. And so then we are pursuing developments for other applications, but in the quantum space, we're focused on developing and manufacturing PIC-based products that enable quantum systems in the photonic-enabled space based on requirements that were made aware by experts in the field. We're not quantum experts, and so then so we have a lot of collaborations with world-class leaders in that space, and they tell us the problems that they need solved, and we solved it. So that being said, like most PIC developers, we reduce the swap, alignment sensitivity, fragility, and the cost of quantum photonic systems. And primarily tackling a few of the problems that were made aware of by specialists in the field. Let me see if I have it on this next page. 1 second. Come on, buddy. All right. So mostly we're laser systems experts, and so then we handle a lot of the issues that we're aware of on the source side, developing ultra-narrow line width lasers, watt level CW lasers, tunable lasers on chip, lasers that are rugged for harsh environments and designed to be optical feedback tolerant at various wavelengths from the NIR to NUV. We also have current developments funded through a lot of our contract work in developing on-chip optical isolators that are compact, low loss, low power, and CMOS compatible on chip. We develop in collaboration with our NIST partners low loss PIC interfaces to atomic vapor cells for trapping and cooling atoms for applications that require it. Clocks, inertial sensors, computers, and all of this in order to develop deployable laser systems with focus on the source, but also the electronics and packaging for stabilization and control and operation in harsh environments. To do this through our programs and internal R&D, we're using heterogeneous and hybrid integration schemes to integrate best-in-class platforms for the applications of interest for you guys, quantum applications. We primarily focus on low-loss silicon and silicon nitride platforms for our routing. A big focus of ours is developing 3.5 electro-optics for gain modulation and detection with DFMA in mind. Like I said, piezo MEMS-based optical isolators on chip, as optical isolation is a big problem in quantum systems. The frequency requirements of quantum systems is much more stringent than telecom, as you're all aware already. And so then this is a big deal. We also have a number of programs developing PIC platforms integrating various nonlinear materials on chip required for those applications, liquid crystal-based compact modulators, thin film lithium niobate modulators integrated into our multi-level silicon nitride PIC platform, trying to develop thick silicon nitride and integration of phase change materials. And then, like I said, through a few different integration schemes, depending on the application space, different schemes are optimal based on the performance required. Yeah, and like I said, we're very early stage, started last year, but we have programs working with the DoD and NASA, yeah, just my wrap up slide. We're a bunch of PIC experts. We're not experts in the field of quantum, so we really would like to hear from people needing partners like us. We want to partner with end users, systems integrators, tier one suppliers, and experts in the field, as well as the developers in academia and industry for state-of-the-art photonics that will enable them. Like I said, we're hiring. Please check out our website. I'm trying to post all the positions there. And feel free to contact me directly if you have any questions or want to talk about collaborations. Thank you.